All right, so yesterday we talked about the dot product. We applied it in a couple of different ways. We used the properties of a dot product, and then we also did the angle between two vectors, okay? So remember, the dot product is how we multiply vectors, because we can't really just multiply them. We can't multiply, and then put them, separate them out by a comma. What we do is called the dot product. So in the dot product, we multiply the first and first, and then the second, and then we add them together at the end, so the result of a dot product is always a single number. So I would do 7 times 2 plus negative 3 times 8, and I'd get 14 minus 24, which is negative 10. So that would be the dot product of U and V. And then number 2 is the angle between. So I gave you the formula yesterday that the angle between two vectors can be found using the cosine of theta equals the dot product of those vectors over the products of their magnitude. And I said if I was making a reference sheet, which obviously I would strongly recommend that you do, I would go a step further and even say that theta equals cosine negative 1 of that, U dot V over the magnitude of U times the magnitude of V. Because what tends to happen is we forget to cosine at the end, okay? It should be like a number that's super small because it should be less than 1. So hopefully that reminds you that there's not a whole lot. I mean, it could be an angle that's that small, but there's not a whole lot of times we get that. And hopefully that's a reminder to do that. But this is kind of question is going to be like, an open-ended free response where you're typing it in, and so you won't be able to catch it. That it wouldn't be you wouldn't do that last step. So if that's the case, then we need the cosine negative 1 of, in this case, U dot V, we already found, right? U dot V was here. This is negative 10 over, then I need the magnitude of U and the magnitude of V. So we find the magnitude by doing the square root of A squared plus B squared. U would be 7 squared plus negative 3 squared, 49 plus 9, square root of 58. And we don't need to simplify these in any way because we're going to let our calculator do the work at the end. So I can leave that as the square root of 58. And then I can find the magnitude of V by doing the square root of 2 squared plus 8 squared, 4 plus 64, square root of 68. So I do the product of those two in the bottom. Now you definitely want to practice using the calculator you're going to use next Friday on your test with these questions, because this is like one of those law of cosines. If you type it wrong into the calculator, it's going to give you an error. It doesn't give you an error. It finds something that's wrong. So you got to be really, really careful. So when I type this into the graphing calculator, I do cosine negative 1. I'm going to do negative 10. That's fine by itself. I don't have to put the parentheses. It already gives me the first parentheses, but I don't need the parentheses again. Then I do divided by. Now I have to open my parentheses. Or I have to keep them both underneath the square root. And you can keep them underneath the same square root. That's fine. 58 times 68. And I'm going to hit enter, and I get that theta is 99.16 degrees. I don't think I told you what to round to. Just keep 2 decimal places. Now, we also said yesterday that if I were to plot these roughly, it doesn't have to be perfect, but if I were to plot these vectors, that I can use that to kind of check to make sure I'm at least on the right track. So if I had a coordinate grid, or if I just drew the 2 lines, because we'll do this quick. I don't want that. There we go. 7, 1, 2, 3, 4, 5, 6, 7, negative 3 would be like that. And then 2, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8 would be like that, which appears to be around a right angle, but a little bit bigger than a right angle, which is consistent with an angle of 99 degrees. So you can, again, if you had extra time, you can kind of plot it out roughly and give yourself that check. Questions on either of those 2 things? Yeah.
For number 2, if they give you U and V as I and J format.
Oh, you don't have to worry about it. So the angle will always be in degrees. Yep. So anytime you're answering a component form, like you're finding the component form of something, and it's giving you an IJ, that's when you want to put it back in IJ.
Yeah, I was only asking because on the homework there's one like that, and I'm like, I don't know where I went wrong.
What? The angle between one?
Yeah.
Yeah, let me see. Well, that's not a good sign. Bad request. Error logging in. We're going to have to go back to that later, Taylor. Unless you know what your numbers were. Do you know what your numbers were?
Yeah, I'm looking at it.
Okay. Mine won't let me log in. Victoria, they ever fix your thing?
They sent me an email that it should be fine, and then I went back.
Did you email them back and say you're wrong? Like, I just feel like, I mean, I think this is ridiculous, but I do think, like, if you have a product, you should be able to provide support for it. And it should work the way that you signed up for it to work. This is not what I want. You need to be aggressive. Speak up. Did you find it, Taylor?
Oh, yeah.
Oh, give me.
U equals
Whoa. U equals
3I minus 4j. And then V equals I minus 3j.
Okay, so this is 3, negative 4, 1, negative 3.
Wait, are you ready?
I sure am. Wow. There it is. Okay, so U dot V would be 3 times 1 plus negative 4 times negative 3, 3 plus 12, 15. And then the magnitude of U, square root of 3 squared plus 4 squared, that's the one that's 25, so it'd be 5. Magnitude of V, square root of 1 squared, negative 3 squared, root 10. Good so far? So then the cosine negative 1 of 15 over 5 root 10. Second cosine 15 divided by, open the parentheses this time because one's underneath the root and one's not. So you got to make sure you do this. 18.43.
Yeah, that's what I got, but
Okay, let me see.
cosine is not like
Let me
that.
see if well, sometimes it's just difficult.
You have to put the parentheses pointy thingies.
No, because it's I love our terminology for it, the parentheses, pointy thingies.
It's really specific.
Yeah,
So.
listen, it works. I know exactly what you're talking about. You have to put the degree symbol. Well, that's fun.
Okay.
It didn't give you the degree symbol, so you got to put that. You will not for your quiz,
Okay.
because I won't be able to give you a degree symbol.
Okay, thank you.
Yeah, that's all you're missing.
Is that
So they basically just took the formula we just had for the angle and we rearranged it to solve for the dot product. So we're finding the dot product, okay? Example 4, find U dot V, where theta is the angle between U and V. So it's giving me U is 5, V is 4, theta is 5 pi over 6. So I do what we just wrote. U dot V would equal the magnitude of U times the magnitude of V times the cosine of 5 pi over 6. So magnitude of U is 5, magnitude of V is 4, cosine of 5 pi over 6. We go back to our unit circle, because that's a unit circle angle. Every over 6 has what coordinate point? Good. So the over 6 is have root 3 over 2, excuse me, and 1/2. 5 pi over 6 would be in my second quadrant, which would make that a negative root 3 over 2 and 1/2. So what's the cosine of that angle? Negative root 3 over 2. I can simplify this, and it would be negative 10 root 3. Questions on that? So dot products in that form will be kept exact. You'll keep a square root. If this was an open-ended answer on your test, it would say negative 10 SQRT, open the parentheses, 3, close the parentheses. So yes, you're going to want to reference your unit circle not only here, but when we move into 6.5, you're going to see that you need it there too. So I would, if I'm building my reference sheet, definitely include my unit circle. All right, orthogonal vectors, which every year is up for debate, whether it's orthogonal or orthogonal. I forget what Siri says. She says one of them. I'm going to go with orthogonal because that's what comes out of my mouth when I say that word. Two vectors that are perpendicular, or vectors that meet at a right angle, because that's what perpendicular means, are orthogonal. Two vectors are orthogonal if and only if the result of their dot product is 0. So if I'm given two vectors, there's actually two ways to determine if they're orthogonal. One is that they're perpendicular, so I could look at their slopes, right? If I'm given 2, 3, and I'm given negative 3, 2, okay, I can do the change in x it would be change in y over change in x, so this would be 3 over 2. This would be change in y over change in x, that would be 2 over negative 3. And if these are opposite reciprocals, then I know they're perpendicular. So that's your previous test. Look at what would be the slope, right? And if I give it to you in component form, it's change in x comma change in y. I just put the second over the first. If they are opposite reciprocals, then these lines are perpendicular. Or I do the dot product. So if I had 2, 3, and negative 3, 2, then the dot product, I would multiply these two together, 2 times negative 3, add it 2, multiply these together, 3 times 2, negative 6 plus 6, which would give me 0. So there's two ways to test to see if they are orthogonal. One is that the slopes are opposite reciprocals. The other is that the dot product of the two would be 0. Parallel vectors have the same slope. This should be switched every year. I forget to switch it. Okay? It can stay that way, but our brains know rise over run, so you might as well keep it rise over run. So again, if I think my U1, U2, and my V1, V2, and put that into slope format, this is my change in Y, this is my change in X, this is my change in Y, this is my change in X. If they are the same, the lines are parallel, right? We know that. Same two rules as before. Perpendicular means that they are opposite reciprocals. Parallel means that they are the same. All right, so the last kind of question from this section will be this. Determine if U and V are parallel, orthogonal, or neither. So the first thing I'm going to do from here is figure out my component form. Well, I could do two things, right? The test for perpendicular only works with the dot product, whereas parallel, you can use your slopes. So my recommendation is you can use the slopes first, okay? If I look at this coordinate point, this would be 2, negative 2, right, for my component form. And this would be negative 1, negative 1. So what would be the slope of U? Negative 1. It'd be negative 2 over 2, which is negative 1. What would be the slope of V? Positive 1. It'd be negative 1 over negative 1, which is positive 1. Are those the same? No, so we've ruled out parallel. Are they opposite reciprocals? Yes. 1 and negative 1 are opposite reciprocals. Okay.
So, or that one?
Yeah.
It's like another word for perpendicular?
Yep.
Oh.
Yep. And you could also use the dot product to check it, right? So 2 times negative 1 plus negative 2 times negative 1, negative 2 plus 2, 0. So the dot product would be 0. You'd still, in a question, if it just said, are they orthogonal, then I could do the dot product and be done with it. But if it's saying are they orthogonal, parallel, or neither, I still need to know the slopes to see if they're parallel. So that's why I would say you can use the slopes. And if neither of these are true, then it's neither. That's it. So in your homework, when you get 3 chances to answer a question and there's only 3 options, we better get this one right, okay? On a test, this is the only multiple choice question on your test, okay? It's either going to be orthogonal, it's either going to be parallel, or it's going to be neither. How could you, yeah.
What did you say for perpendicular, opposite, reciprocal? What's that?
Like change the sign and flip the fraction.
Okay, thank you.
You're welcome. So the other thing you could do here is check this, right, by drawing these 2 out. So if I plot 2, -2, right 2, down 2, it looks like that. If I plot -1, -1, -1, -1, it looks like that. And then ask yourself, does that look like a right angle? It's definitely not parallel, right? It looks pretty close to a right angle, which confirms what we just said, which is that they would be orthogonal, which is that they are perpendicular. Questions?